Earth hides 124 light-years away from us, and orbiting this faint celestial body is a planet that could fundamentally alter our understanding of life in the universe. Its name is K2-18b, and this is not its first time in the scientific spotlight. But now the reasons are far more compelling and perhaps historic. A team of astrophysicists from Cambridge, working with data from NASA's ultra-sensitive James Webb Space Telescope, has discovered chemical compounds in the planet's atmosphere that, on Earth, are produced exclusively by living organisms. The substances in question are dimethyl sulfide, DMS, and dimethyl disulfide, DMDS. On our planet, these gases are typically associated with marine plankton and certain bacteria. What they are doing in the skies of a distant exoplanet is still a mystery, but a mystery that might point toward extraterrestrial life. Professor Niku Madhusudan, the lead researcher on the project, calls this the most convincing evidence to date of potential life beyond Earth. If our interpretation is correct, he says, we could confirm it within a year or two. Perhaps the most astonishing part of the discovery is the quantity. The concentration of DMS found in the atmosphere of K2-18b appears to be thousands of times higher than equivalent levels on Earth. If this is not a mistake or observational artifact, we may be looking at an entire world teeming with life. But scientists, including Madhusudan's own team, urge caution. The current data, while impressive, still falls short of the rigorous standards required for a formal scientific discovery. To claim definitive proof, they need a statistical confidence level of 99.9999%, known as the 5 sigma threshold. At present, the result stands at 3 sigma, or 99.7%, a significant improvement from previous estimates of 68%, but still not enough. Other researchers and independent experts echo the cautious tone. Astronomer Catherine Hamans, for instance, emphasizes that even with reliable data, we cannot say with absolute certainty that DMS and DMDS originate from biological processes. The universe is vast and filled with exotic phenomena. We still don't fully understand what can happen inside such alien worlds. The intrigue surrounding K2-18b isn't based solely on its mysterious chemistry. The planet is roughly 2.6 times the size of Earth, and data suggests it has an atmosphere where ammonia is notably absent, a gas that should be present in a dry, oceanless world. This absence points to a compelling hypothesis: the presence of a vast subsurface ocean. And where there's water, the possibility of life follows. However, alternative scenarios remain. The ocean might consist not of water, but of magma, a revelation that would crush hopes for life. Adding complexity, the planet's very structure is under debate. Some models describe K2-18b as a mini-gas giant with no solid surface. That would render the world utterly inhospitable to life, at least any form of life we currently comprehend. Still, despite all the ifs and buts, the scientific community remains deeply intrigued. The Cambridge team is collaborating with other research institutions to investigate whether the detected molecules could be synthesized through non-biological means in laboratory settings. If such synthesis proves impossible, the case for a biological origin becomes far stronger. Professor Subir Sarkar, another member of the project, is careful with his conclusions, yet he acknowledges that the possible presence of an ocean makes K2-18b one of the most promising candidates in the quest for alien life. His message is simple and clear: watch this space. Cambridge astrophysicist Oliver Shortall, however, brings us back to reality. He reminds us that all of our knowledge about distant exoplanets is drawn from faint threads of light passing through their atmospheres. Interpreting those signals is like trying to read a smudged and half-burnt map, prone to error, to bias, to misinterpretation. Each promising signal could be either a whisper of life or a trick of the cosmic light. Yet the implications are impossible to ignore. Even the slightest probability of a biological origin for these gases elevates the conversation. This isn't just about chemistry. It's about existence. About the possibility that we may not be the only ones looking up into the void. Public curiosity has surged alongside scientific interest. News of K2-18b's chemical profile has lit up headlines, podcasts, classrooms, and conspiracy forums alike. Some hail it as our first real evidence of alien life. Others urge restraint, cautioning against the seduction of sensationalism. But in a world starved for wonder, K2-18b delivers, even if only as a promise. Further missions are already being drafted. Telescopes in space and observatories on Earth are preparing to lock their gaze on this distant enigma. New instruments, refined spectrographs, and smarter algorithms will seek to strip away more layers of the mystery. Every spectrographic fingerprint, every spectral dip in starlight brings us a little closer to confirmation, or recalibration. Science moves not with leaps of faith, but with patient, deliberate steps. And yet, some steps feel bigger than others. When we look at K2-18b, we don't just see another planet. We see a question written across the stars: are we alone? As Madhusudan puts it, decades from now, we may look back at this moment and realize it was the beginning, the dawn of a new cosmic chapter. The moment humanity first saw the glimmer of a living universe beyond the solar system. The discovery hasn't been made yet, but the journey has begun, and that alone is already extraordinary.
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light-years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than -360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn, or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just 1 day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP 76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP 76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP 76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation. This planet is as light as that piece of fluff stuck to your sweater. In the scientific world, it's called WASP 193b. But let's call it the Cotton Candy Planet. It's located around 1,200 light-years away from us. Sure thing we'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin, 50% more massive. It has an extremely low density combined with other factors, such as high temperatures and the infrared brightness of its host star, that make it look special. May I have a close-up here, please? Thank you. See how fluffy it is? Right now, you understand that it would be impossible to stand on its surface. Anyways, it's not often that you meet something like WASP 193b at a planetary party. Such planets might be fluffy because they're getting cooked by their parent stars, puffing up like a marshmallow that's seen too much campfire action. But the thing is, if you're that close to your star and mostly made of a hydrogen-helium cocktail, you're not gonna keep your puffiness for long. It's like trying to hold on to a balloon during a hurricane. Exoplanets like this fluffy guy here are pretty rare, but there's also WASP 100-07b, and it looks squishy too. This one kicks back 200 light-years from us, and it chose the constellation of Virgo as its official residence. From some perspective, you might say that this planet is a copycat of Earth. It has helium, and its atmosphere contains sulfur dioxide. There's some resemblance for sure, but WASP 100-07b has the density of a marshmallow. It means we can snoop through its atmosphere easier than we could with a heavyweight like Jupiter. Scientists were beyond surprised when they peered through their super space goggles, the James Webb Space Telescope's MIRI-cam. They spotted clouds made of the stuff that builds beaches, silicate, or as you might know it, sand. Imagine sandcastles in the sky. Those sound clouds are way up there in the penthouse suite of WASP 100-07b's atmosphere, where the thermostat reads a breezy 932 degrees Fahrenheit. Normally, you'd need 1,832 degrees Fahrenheit to cook up this kind of cloud, so scientists are scratching their heads. How did those grainy puffs get all the way up there? Turns out, WASP 100-07b might be running its own sandy water cycle, but with scorching silicates instead of H2O. Silicate particles get whooshed up from the sizzling lower levels by some sort of cosmic elevator, and then they cool off, party together as clouds, and sprinkle down a silicate drizzle. Nobody's packing sunscreen for this kind of sandstorm, though. Now look at this Kepler planet family located in the Kepler 51 star system. This cosmic three-pack hangs around 2,400 light-years away, looking huge but having the same density as your favorite snack. And it's cotton candy yet again. Scientists have been digging into what these space treats are made of. They now believe these puffball planets are big hydrogen-helium gas balloons with a generous smearing of methane haze. It also turns out these planets might be going through a cosmic downsize. Now, let's talk about a planet called Mascara 5b. Nope, it doesn't look like one of those cosmetic tubes from your mom's drawer. Scientists say it's one of the hottest planets ever discovered. They call it an ultra-hot Jupiter, showing off its impressive size, almost twice as big as our very own Jupiter. The dayside temperature is around a scorching 4,892 degrees Fahrenheit, while the night side hits 4,172 degrees Fahrenheit. No chance for any sort of life to survive out there. Actually, it's the second hottest nightside temperature ever recorded. To put it in perspective, the temperature of molten lava sits between 1,292 degrees Fahrenheit and 2,282 degrees Fahrenheit. So, the planet is a whole lot hotter than this scorching liquid rock. Its temperatures even surpass the melting point of most metals, which is around 3,632 degrees Fahrenheit. Scientists mention that the insane heat on this planet is comparable to the exhaust of a rocket engine. Back in 2005, one famous star called... Wait, is that a name or a phone number? Whatever. So, turns out this star has a hot sister, and they have very similar names. This hot sister has B at the end. Well, this place looks like something from a sci-fi movie as it rocks a mesmerizing blue marble vibe, according to NASA. Such an appearance results from an atmosphere packed with hazy clouds laced with glass. The rain on this planet is glass-filled precipitation that likes to fall sideways, thanks to fierce winds blowing at a speed of 5,400 miles per hour. And yeah, it's the hot sister for a reason. Scientists have measured the daytime temperatures in this nightmarish world. It's around 1,700 degrees Fahrenheit. So when it rains on this planet, it's more like molten glass pouring down instead of your typical waterworks. You may not know it, but space is swarming with wasps. I'm talking about planets called WASP. Meet WASP 76b. This sizzling hot Jupiter-like planet is so out of this world, it rains iron at night there. The daytime side is no less of a fiery nightmare. The temperature there is about 4,300 degrees Fahrenheit. WASP 76b may be slightly smaller than Jupiter, but don't underestimate its grandeur. This fireball is located 640 light-years away from Earth. And its terrifying climate is the result of one seriously extreme orbit. You see, these gas giants are fittingly known as hot Jupiters. They like to keep it hot, so they orbit way too close to their scorching host stars. In this case, WASP 76b is nearly 10 times closer to its star than Mercury is to our Sun. That's way too close for comfort, leaving this rebellious planet tidally locked to the star. So, while one side basks in eternal light, the other is trapped in perpetual darkness. 55 Cancri E is a total gem. It's the raddest super-Earth ever spotted. Scientists initially believed it was packed with so much carbon that its insides were blinged out with diamonds, thanks to insane pressure and sizzling temperatures of 4,892 degrees Fahrenheit. But researchers put a dent in the diamond hype, showing there was actually less carbon than we had originally thought. Well, diamonds aren't actually that rare and expensive after all. They're just well marketed. The last destination for today is GJ 1214b, located 40 light-years away from Earth. This planet is like a supersized Earth, almost 3 times bigger in diameter and a whopping 7 times heavier. It orbits around its red dwarf star faster than you can finish a pizza, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on GJ 1214b create some super cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo on being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors, though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Bernard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is... no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Bernard's star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms, of course. Only the Alpha Centauri trio is closer to us. Bernard's star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Bernard's star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Bernard's star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Bernard's star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Bernard's star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Barnard's star is tricky because, in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super-sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs, like Barnard's star, are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory, rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face-on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real Smartie. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation. Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered 2 other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, They certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the two other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars.
Our Sun is an average-sized star, and still, it could fit 1,300,000 Earths. The star is also 333,000 times as heavy as our planet. NASA has translated radio waves created by planets' atmospheres into audible sounds. That's how astronomers found out that Neptune sounds like ocean waves, Jupiter like being underwater, and Saturn's voice resembles background music to a horror movie. Here on Earth, it's bebop jazz. No, I made that up. The Sun's surface is scorching hot, but a bolt of lightning is 5 times hotter. Earth gets struck by 100 lightning bolts every second, which results in 8 million lightning strikes a day and around 3 billion a year. Ooh, shocking. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1 million years over there. Because the moon doesn't have an atmosphere. There are no winds, not even a breeze, that can slowly erase those footprints. Astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bored and wanted to check how things are going in the direction of the cold spot. That's an anomaly in the Cosmic Microwave Background Map, or CMB for short. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. So you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort. Rather significant, to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than the Sun. Their event horizon is wide, and the gravity doesn't change as quickly. So, the force you'll feel at your heels and at the top of your head will be about the same. And you can go all the way to the heart of the black hole. This myth is busted. If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around the eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, that's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space, well. Once they explode, stars aren't supposed to come back to life. But some of the stars somehow has survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 40-365. It's a partially burnt white dwarf. A white dwarf is a star that burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. If you ever go into space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news, the skin is elastic enough to hold you together, which means you wouldn't explode. Small comfort. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. This happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it into another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like for a billion suns, but luckily it's far away from us. If you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yes, we often hear the sound of spaceships and battles in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you, the sound wave begins to push the first air molecule next to the clap, then the second, third, and so on, until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. So, to carry on a conversation, you'd either need a radio or really good lip-reading skills. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space. But they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. And there's a lot of it. It may even make 25% of the universe. Dark energy makes the other 70% of the universe. That adds up to 100, right? Now, let's look at the moon. It always looks at us with one side. This means the moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So whenever you look at the moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. Yeehaw! One myth that turned out to be untrue is that people have never actually been on the moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the moon perfectly. Now, the astronauts didn't need them when they left the moon and tossed them when the moonwalk was over. They left a lot of stuff there, too. They even tossed the armrests of the seats in the lunar module to reduce the weight. Now, counting all the Apollo lunar missions, the total weight of rubbish on the moon is approximately 187 tons, including several lunar rovers, spacecraft debris, 6 lunar modules, and all the experiments left behind. That's like 3 Boeing 737s. Another myth about the sun is that it's yellow. Let's send you into space for this one. You look out the window and it's white. The sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our sun. But young and very hot stars are bright blue. The sun is about in the middle of this spectrum. Oh, one more myth about asteroids. We need to fly a little farther than Mars's orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid clouds. Not true. The fact is that space is huge and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the Moon, so there really aren't that many of them there. To understand the dimension of the emptiness in space, look at the collision of two galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here. Venus most likely used to be covered with oceans, from 30 to 1,000 feet deep. Also, some water was locked in the soil of the planet. On top of that, Venus had stable temperatures of 68 to 122 degrees Fahrenheit, which, you have to admit, was quite pleasant and not that different from the temperatures on Earth nowadays. So, what I'm getting at is that for 3 billion years, right until something irrevocable happened 700 million years ago, Venus could have been habitable. But now it's not. The Moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. Neutron stars are some of the smallest yet most massive objects in space. They're usually about 12 miles in diameter, but are several times heavier than the Sun. Oh, and they also spin about 600 times per second, far faster than your average figure skater. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. And still, because of its large volume, the planet is 95 times more massive than Earth. A transient lunar phenomenon is one of the most enigmatic things happening on the Moon. It's a short-lived light, color, or some other change on the satellite surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the Moon. One of the mission participants noticed that one part of the lunar surface was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. Trash isn't just a problem in Earth's oceans, cities, and forests. There is a thing called space junk, which is any human-made object that's been left in space and now serves no purpose. There's also natural debris from meteoroids and other cosmic objects. There are currently over 500,000 pieces of space debris orbiting the Earth at speeds high enough to cause significant damage if they were to collide with a spacecraft or satellite. NASA does its best to track every single object to ensure that missions outside Earth can reach their destination safely. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. The Sun's temperature is hotter than the surface of a star. The surface temperature reaches 10,000 degrees Fahrenheit, but the upper atmosphere heats up to millions of degrees. If someone could dig a tunnel straight into the center of the planet and out the opposite side, and you were adventurous enough to jump into it, it would take you 42 minutes to fall to the other side. You'd speed up as you fell, reaching maximum speed by the time you reached Earth's core. After the halfway point, you would then fall upwards, getting slower and slower. By the time you reached the opposite surface, your speed would be back to zero. Unless you managed to climb out of the hole, you'd immediately start falling again, back down or up to the other side of the planet. This trip would go on forever, all thanks to the weird effects of gravity. Hey, might be a fun way to spend an afternoon. There might be more metals, for example, titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? it contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon was formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. Or maybe, as they've been saying for centuries, it's made of green cheese. Earth could have been purple before it turned blue and green. One scientist has a theory that a substance existed in ancient microbes before chlorophyll. That thing that makes plants green evolved on Earth. This substance reflected sunlight in red and violet colors, which combined to make purple. If true, the young Earth may have been teeming with strange purple-colored critters before all the green stuff appeared. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest, the Earth's highest mountain above sea level. If you were standing on top of Olympus Mons, you wouldn't understand you were standing on a mountain. Its slopes would be hidden by the planet's curvature. Astronomers have found a massive reservoir of water in space, the largest ever detected. Too bad it's also the farthest, 12 billion light-years away from us. The water vapor cloud holds 140 trillion times as much water as all the Earth's oceans combined. What are we supposed to do with that information? Venus spins at its own unhurried pace. A full rotation takes 243 Earth days, and it takes the planet a bit less than 225 Earth days to go all the way around the Sun. It means a day on Venus is longer than a year. There's very little seismic activity going on inside the Moon, yet many moonquakes caused by our planet's gravitational pull sometimes happen several miles below the surface. After that, tiny cracks and fissures appear in the satellite surface, and gases escape through them. Hey, they sometimes escape from me, too. Now, Mars is the last of the inner planets, which are also called terrestrial since they're made up of rocks and metals. The red planet has a core made mostly of iron, nickel, and sulfur. It's between 900 and 1200 miles across. The core doesn't move. That's why Mars lacks a planet-wide magnetic field. The weak magnetic field it has is just 1/100th% of the Earth's. When the planets in the solar system were just starting to form, Earth didn't have a moon for the longest time. It took 100 million years for our natural satellite to appear. There are several theories as to how the moon came into existence, but the prevailing one is the fission theory. Somebody went fishing and caught the moon? Actually, no. The fission theory proposes that the moon was formed when an object collided with Earth, sending particles flying above. Gravity pulled the particles together, and the moon was created. It eventually settled down on the Earth's ecliptic plane, which is the path that the moon orbits. So, looks like the green cheese is off the table now. The largest single living thing on Earth turns out to be a mushroom in Oregon. This enormous honey mushroom lives in Malheur National Forest and covers an area of 3.7 square miles. It could be as much as 8,500 years old. You could be forgiven for missing it, though, since most of it's hidden underground. When the roots of individual honey mushrooms meet, they can fuse together to become a single fungus, which explains how this one got so big. If you could gather all that mushrooming stuff into one big ball, it could weigh as much as 35,000 tons. That's about as heavy as 200 gray whales. Hey, that's a whale of a mushroom. Hehe. The largest asteroid in the solar system is called Vesta, and it's so big that it's sometimes even called a dwarf planet. A trip to the nearest star, apart from the Sun, would take you 5 million years on a commercial airplane. That's what I call a long-haul flight. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? Well, you don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Now, some scientists believe that our planet used to have an additional satellite. According to their research, a small celestial body about 750 miles wide orbited Earth like a second moon. It most likely crashed into our main satellite later on. Such a collision could explain why the two sides of the moon look so different from each other, one being heavily cratered and rough. Or it could be the green cheese.
The Moon. A beautiful, natural satellite with some mysterious dark splotches. We always see only one side of it, so we're used to this image. It's hard to imagine the Moon looking any other way. But it used to be different. Oh ho ho, it used to be so different. Picture this, a huge incandescent satellite in the sky that is causing constant tsunamis. I suggest we go very far into the past to see what the Moon was like many, many years ago. The Moon formed around 4.5 billion years ago. At that time, our green-blue planet was still a red-hot, insanely unstable piece of rock flying in space. We didn't have the Moon yet, and a day on our planet only lasted 6 hours, which meant only 3 hours of daylight. Volcanoes erupted all over the place, releasing poisonous gas into the air, and a bunch of meteorites regularly crashed into the planet. At the same time, 4.5 billion years ago, the so-called Big Splash occurred, or, as scientists call it, the Giant Impact Hypothesis. It claims that once an object the size of Mars crashed into Earth. Mars is about 2 times as small as our planet, so the blow wasn't too bad, but it was quite catastrophic. This powerful impact tore off part of the outer layers of that Mars-sized object and Earth. The very core of this space body merged with Earth's own dense core, and a huge number of fragments of Earth flew into outer space. So, this was the beginning of our Moon, or, saying in a scientific way, the process of differentiation has begun. This is the process all planetary bodies go through at the beginning of their lives. Since the impact was very hot, its heat carried away most of the gases and liquids from the broken pieces of Earth. Only a relatively dry stone surface remained. So yeah, there is water and gases on the Moon, but in very small quantities. The gravity of our planet was strong enough to make all these hot stone fragments stay in its orbit, and they gradually began to stick together. The chemicals they contained were distributed in layers. Iron, which was heavier, sank deeper inside, and lighter elements formed the surface. In a short time, 100 years or less, the ring of steam, dust, and molten rock fused together. The largest clusters with the strongest gravity attracted more and more particles, gradually forming the Moon. It looked like a red-hot bubble ball. Sadly, the nucleus of this newborn Moon turned out to be very small. It lacked iron and other heavy elements to form into something substantial, like a planet. The oldest rocks of the Moon probably formed in the ocean of magma. And when the Moon gradually cooled down, it turned out to be a white, clean, and perfectly even ball. But it was still completely different from what we have now. To begin with, immediately after its birth, the satellite was located at a distance of only 13,500 miles away from Earth. This is 15 times closer than it is now, around 238,000 miles. It's scary to imagine how huge and bright the Moon looked in the sky at that moment. The view was probably both beautiful and terrifying. And, of course, such proximity caused incredibly huge waves on Earth. The planet experienced regular tsunamis. Also, at that time, the Moon was spinning very fast, and it wasn't turned to Earth with only one side. But, in general, Earth and the Moon had a positive impact on each other. For example, it was the Moon that made our day last 24 hours. Now, Earth's axis is mostly tilted 23.5 degrees from the plane of its orbit around the Sun. Without the Moon, Earth rotated rapidly, but thanks to the satellite, the planet's tilt stabilized, which led to a wide and pleasant variety of climates on Earth. To be fair, the gravity of our planet also helped the Moon. Thanks to it, the Moon began to rotate more and more slowly while gradually moving away from us. Over the years, its orbit has moved far away from our planet. At the same time, the Moon became tidally locked to Earth. This means that its rotation period coincides with its orbital period. Or, in other words, the moon moves around itself as fast as it moves around the Earth. That's why the moon always faces our planet with only one side. When the moon moved away, tides on Earth became calmer. Now, water could flow to the most remote corners of our planet. It was then that life appeared on Earth. But back to the evolution of the moon itself. What was happening on its surface after its formation? The next stages of the moon's development were childhood and adolescence. And as is usually the case at this stage, this period was insane. No wonder, about 4 billion years ago, the solar system was going crazy. During the first 600 million years of the moon's existence, large asteroids and comets constantly collided with it. Now, they were bothering not only our Earth, but also its satellite. These impacts were the most powerful in the history of the moon. They left many large craters, which were later filled with dark rock. So, Earth wasn't enough for you, huh, space? Once, a dwarf planet crashed into the moon. It was about the size of Ceres, the largest object in the asteroid belt between Mars and Jupiter. This explosion formed the SPA basin and also forever changed the appearance of the moon. Can you see that dark spot on the far side of the moon? Right there in this very south? This spot is called the South Pole Aitken Basin. Its diameter is about 1,600 miles. And yes, it was formed by the impact I've mentioned about 4.3 billion years ago. This planet brought with it a bunch of complex and strange chemical compounds that scientists are now finding all over the far surface of the moon. These compounds began to emit a lot of heat, melted part of the lunar mantle, and, oops, accidentally woke up volcanoes. The volcanoes began to erupt furiously. A huge amount of magma was distributed over the surface of the moon. Many years later, it cooled down, leaving behind those famous dark splotches that we're so used to. They're called the lunar maria. There are much fewer craters there than on the lunar highlands. But for the last billion years, the moon has been geologically inactive, except for occasional collisions with meteorites. In general, the appearance of the moon changed forever as a result of these events, and, battered and tired, it entered adulthood. But even then, it couldn't get any peace. A bunch of meteorites decided to bother it again. Honestly, it wasn't that bad. There were many collisions, but all of them were quite small. They just left a bunch of craters and pits on the moon and maybe damaged its mantle a little. Some of the collisions deepened already existing large craters. The moon's crust was getting thinner and thinner over the years because of all the chaos going on. And now we call this upper part of the lunar crust covered with craters the lunar highlands. All those white and bright areas of the moon, the highlands. But in the end, the universe finally calmed down, for now at least, and the moon began to look the way it does today. There are still many things we don't know about Earth's natural satellite. There are moments in its history that scientists still can't accurately explain, but they're continuing to study our beautiful satellite. The data about the moon is useful to people not only for its own sake. It gives us a more complete picture of both the history of our solar system and space as a whole. So, let's hope that one day we'll be able to find out everything there is to know about the moon.
Imagine a basketball spinning on someone's finger. A point near the middle of the ball takes longer to spin back to where it started than the spot where your finger is. Earth spins in much the same way. People in the center of Africa are turning at 1,000 miles per hour as the planet rotates, while anyone at the South Pole doesn't really move at all, other than rotating in place. At the same time, we're all moving forward through space equally fast, since the planet is also hurtling around the sun at 67,000 miles per hour. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees Fahrenheit. That's as hot as the surface of the sun. And the pressure there is 3.3 million times the atmospheric pressure at sea level. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. The movement of galaxies and clusters billions of light years away from us suggests there's some enormously massive body outside the visible universe. After billions of years, the expansion of the universe will make the space so sparse that we won't be able to see the stars in the sky at all. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. But it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Astronomers know for sure that the universe is growing bigger, and the speed at which it's ballooning is increasing all the time. But if the whole thing is swelling into something bigger, then it must have some kind of an edge, right? It's unlikely that people will ever find out, but if so, then what would it be? A ginormous brick wall and then nothing? An abyss that leads to nowhere? The most common theory is that the universe is shaped in such a way that it can't have an edge, but it's not the only idea. Another theory is even more difficult to comprehend. The universe is, indeed, infinite, and our part of it isn't that unique. It means that somewhere out there, there's another you, or rather, other you. One of them is just a bit shorter, another wears their hair in a different way, and the third one is identical to you in all possible ways. There's also a theory about a multi-universe that consists of many smaller universes, and the universe we live in is just a tiny bubble among other similar bubbles. Those scientists who support this idea are also sure that bubble universes can come into contact with one another. Then gravity starts to flow between them, and when 2 or 3 universes connect, a big bang occurs, just like the one that created our home universe. Neptune is the windiest place in the solar system. Clouds of frozen methane are whipped across the planet at a speed of 1,200 miles per hour. Neptune's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times bigger than that of Earth. The temperature inside reaches 9,000 degrees Fahrenheit. Astronomers also believe that at a depth of 4,500 miles, there might be a diamond layer where it's raining diamond crystals. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. At around a quarter of the size of Earth, the Moon is pretty enormous relative to other satellites out in space. There's nothing quite like this situation anywhere else in the solar system. Pluto has a moon that's almost half as big as itself, but it's more like a twin than a satellite. There are more than 150 moons in our solar system, and Earth's is the 5th largest out of the whole lot. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface. About 30 miles long and 60 miles wide, The caves likely to be the result of 3-billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface discovered by NASA might be the openings to lava tubes. We can't dig up most of Earth's gold. 99% of it ended up in the center of the planet several billion years ago, attracted by the iron in Earth's core. We're talking about 1.6 quadrillion tons of gold here. That's enough to coat the entire planet's surface in 1.5 feet of the stuff. And if all those meteorites hadn't later smashed into the ground, bringing extra amounts of gold, it would be even rarer. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden underneath the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared on the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in the Earth's oceans. It's one of the oldest, largest, and, at more than 12 billion light-years away, one of the farthest things known to humankind. Astronauts in space can lose about 1% of their muscle mass each month. To prevent this, they have to stick to an exercise regimen that lasts 2 hours every single day. The Milky Way galaxy and the Andromeda galaxy are going to meet in 3.75 billion years. They're moving toward each other at a breakneck speed. When the two galaxies collide, they'll form a huge elliptical galaxy. I won't be around then. Have you ever looked up at the night sky and tried to count all the stars? Yeah, good luck. Our galaxy, the Milky Way, has about 100 billion stars, but other estimates put it at over 200 billion, since calculating the exact amount is an almost impossible task, even for astronomers. As for the entire universe, there are at least 1 billion trillion stars. That's one with 21 zeros after it. For comparison, that means there are more stars in space than there are grains of sand on all of the Earth's beaches.
Now look at this fancy granite kitchen countertop. This one can also be available on the moon. I mean, there's no production whatsoever as of now, but there's enough raw materials for the kitchen of your dreams. And by the way, granite on the moon can even prove this dark horse had plenty of water at some point. So it all started when scientists found this weird blob of heat on the far side of the moon. It's all because of a massive chunk of granite that's buried underground. Apparently, granite is pretty rare outside of Earth, so this is a big deal. According to the researchers, there's this old volcano on the moon that hasn't erupted in like 3.5 billion years. But it turns out it's still giving off some serious radiation. The scientists used a fancy new method with microwaves to measure the temperature below the moon's surface. They found this area that's about 31 miles across, where it's like 18 degrees warmer than the rest of the place. And it's right under a spot that collapsed and is full of silicon. It's not as thriving as Silicon Valley back on Earth, it's just a volcanic crater, but without all the lava spewing out. The scientists even compared it to those granite rocks you see in Yosemite, like El Capitan and Half Dome. You know, those giant rocks that look super majestic? Well, apparently, they're made of the same stuff. Researchers claim that granite is super common on Earth, but not anywhere else in our solar system. So, this could change everything we know about other rocky planets. Right, now we know there's granite on the moon, but why is that important to us? So, you know how granite forms on Earth? It's all thanks to water and plate tectonics teaming up to create these huge blobs of melted rock beneath the surface. But guess what? The moon doesn't have any of that action going on, which makes granite super rare up there. But this discovery could give us some clues about what the moon was like back in the day when it had volcanic activity. Without water, making granite becomes a real challenge. But somehow, someway, they found granite on the moon. No water, no plate tectonics, but still, we got granite. So what does that mean? Did the moon have water in this one spot? Or was it just ridiculously hot? I guess we'll need to give a tad more time for the scientists to figure it out. The water on the moon is an issue, though. Duh. As of now, the moon is bigger than the Sahara Desert, but somehow 100 times drier. Astronomers have been debating for ages whether there's any water on this celestial neighbor of ours. But in 2020, NASA's SOFIA mission finally confirmed that there is indeed water on the sunlit part of the lunar surface. Turns out those grains of lunar dust have little molecules of H2O hanging out on them. Back in 1645, when people first started gazing at the moon, they were fascinated by these dark spots all over its surface. Dutch astronomer Michael van Lengren even made a map and called these spots Maria, which means seas in Latin. Sorry, Michael, they're just actually plains of basalt from ancient volcanic eruptions, but we still use the term Maria today. In 1892, an American astronomer named William Pickering discovered that the moon has practically no atmosphere. No clouds, no atmosphere, no chance for water to stick around. So, scientists started thinking that the moon was as dry as a desert. But then, in the 1960s, a theoretical physicist named Kenneth Watson came along with an idea. He suggested that water ice could actually exist in the shadowy craters of the moon that never see sunlight. These areas are called permanently shadowed regions. It was a mind-blowing concept at the time. The Apollo missions from 1969 to 1972 finally gave us the chance to look for water on the moon up close and personal. But when the astronauts brought back soil samples, there was no sign of water. So everyone went back to thinking the moon was bone dry. However, in 1994, NASA's Clementine mission suggested that there might be ice in these shadowed craters after all. And in 1998, the Lunar Prospector mission found evidence of hydrogen concentrations in the permanently shadowed areas. This was a strong indication of water ice at the lunar poles. The images weren't super clear, but it was still an exciting discovery. And finally, in 2008, scientists decided to take another look at those Apollo samples. They revisited the old data and found some hints that there might be water after all. It was like finding buried treasure in your own backyard. As you can see, the moon is a pretty promising destination. It even has enough stuff to produce your food supplements – calcium, magnesium, you name it. Just kidding, it's not the best idea to munch on them to boost your diet. But there are a bunch of other applications they can be used for. Calcium is like the fourth most popular element hanging out in the lunar highlands. But here's the cool part. Pure calcium metal is actually super flexible and can conduct electricity like a boss when there's no oxygen around. Who knew, right? Anorthite is a rare gem here on Earth, but up on the moon, it's partly central for calcium. It can even help make those groovy silicon-based solar cells. To make them, you need some lunar silicon, iron, titanium oxide, and of course, our buddy calcium and aluminum. It's like a recipe for solar success up there in space. The moon even has precious metals like gold. In 2009, NASA was on a lunar mission and they found some gold in the lunar soil. They had a spacecraft right behind the rocket, equipped with a fancy spectrometer. Its job was to study all the debris that got released when the rocket crashed. And they found all sorts of chemicals, like carbon monoxide, carbon dioxide, ammonia, sodium, hydrogen, and even a little bit of mercury, gold, and silver. Hey, vampires beware. Now I know it's been quite a while since then, like 14 years to be exact, but measuring how much gold is actually there has been a real challenge. You see, it's hiding deep beneath the lunar regolith, making it tricky to get an accurate count. Yeah, metals are fun and lunar water may have existed, but what about food? Good news, everyone! Scientists are saying that plants can actually grow on the moon, but don't expect a luscious orchard. It'll be more like a moderate garden with just a couple of beds. Here's the scoop. A while back, those awesome Apollo astronauts collected samples of lunar surface material called regolith and brought them back to Earth. Fast forward 50 years, and NASA decided to use 3 of those samples to try growing plants for the very first time. They used dirt from under the lunar rover bumper to grow these plants. The team added water and seeds to the samples, giving each plant a gram of regolith. Then they placed them in a clean room and added nutrient solutions every day. And they succeeded. During that challenge, the brilliant minds dealt with small plants like mustard greens in the nutrient-poor lunar soil. Yeah, we'll have to export olive oil from Earth to dress it. So, plants can indeed grow in the moon's soil. However, they won't be as strong and healthy as the ones grown on good old Earth soil, or even the ones in the control group grown in a lunar simulant made of volcanic ash. But hey, it's just a start. We're still to find out if our dear moon is hiding more treasures.
Hello, Brightsiders! Today, we have a very unusual topic. We are discussing toilets in space. Do you know that the first astronauts didn't have a toilet at all? The first American astronaut and the second man in space, Alan Shepard, found himself in a very awkward situation. His flight was only supposed to last 15 minutes, so the engineers didn't install any toilet inside his spacecraft. Shepard took his seat in the spaceship about an hour before the scheduled launch. But due to weather conditions and technical problems, the rocket launch was delayed by 2 hours. Alan Shepard was lying on his back in the spaceship all this time. At one point, he felt the need to go number 1. He reported it to ground control, but if Alan Shepard got out of the rocket to do his business, it would delay the rocket launch indefinitely. So, ground control didn't let him out of the rocket. The only option for him was to try and relax. In the end, he did his business right inside his suit. It's a good thing his spacesuit and the clothes underneath were made of cotton, which is quite absorbent and soaked up all the liquid. So, Alan Shepard completed his flight in comfort and relatively dry. Though he still needed to turn off the sensors in his suit because if they got wet, they could cause a short circuit. But the first man in space, Yuri Gagarin, managed to solve the same problem before the rocket was launched. When he was transported to the rocket by bus, a couple of minutes before they arrived at the rocket, he asked for a stop and relieved himself. This way, Yuri Gagarin made his nearly 2-hour flight in comfort. So remember, always go to the restroom before a long trip. Later, NASA took care of astronauts' call of nature using the following device as they sent people into space on more extended missions. It consisted of a cylinder that an astronaut had to put on. Astronauts placed this system on straps near their waists. This cylinder was connected to a bag that collected all the waste. That was the first NASA toilet, comfortable and cheap. NASA also tried to experiment with astronauts' diets. It was all about slowing down the digestive process and prolonging the time between eating food and drinking water to produce waste. One of the astronauts, John Glenn, tried this method out. His flight around Earth lasted about 5 hours. A special diet and medication allowed the astronaut to avoid the call of nature for a relatively long time. He did his business right before re-entering the atmosphere. When scientists analyzed his waste, they found out that its volume was 35% more than the average person's bladder could hold at maximum capacity. But the astronaut had no complaints about his condition, and he said the flight had been quite comfortable. I know that now when astronauts spend time inside a space station or a spacecraft in outer space, they sometimes wear their spacesuits for up to 9 hours. It means that using the regular toilet on board isn't really an option. The solution to this problem is simple: diapers. They are more advanced than the ones sold on Earth, of course, with a special absorbent sewn into the fabric. It can keep an astronaut's body dry for a long time. As you already know, I'm a high school teacher. If we went with my students on a school excursion to the International Space Station, the first question they would ask would probably be, "Tom, where's the restroom?" Well, of course, they would be also excited to learn about the cosmos, but it turns out that using a restroom in zero gravity might be quite a challenge, for which one needs to be prepared. If you take a hose in your backyard and start watering your flowers, the water comes out in a solid stream. The gravity captures it and falls where you aim. And in space, as you know, there's almost no gravity. So the water that comes out of the hose keeps flying in the same direction. And if you have to hit a precise target, it's even more difficult. The stream can break into droplets. They will start bouncing off the walls, going down and flying up. So if you're trying to use a regular toilet in space, you would be surrounded by flying droplets. The solution to this problem is to create a force that will attract the waste. If not gravity, then vacuum. Like the one we have in airplane toilets. After pressing the flush button there, you always hear a humming sound. That's the fan that starts pumping the air out of the waste tank. When the pressure is low enough, the hole in the drain opens and all the waste is instantly pulled down. And this is how the space toilet works at the International Space Station, where you have to create such vacuum from the very beginning. This way, the hose water will form a stream, not because of gravity, but the air pulled inside by a fan. Oh, and regular toilets won't do. If you need to use the bathroom on the ISS, you need to take a hose and turn the toilet on with a button. The fan inside will start spinning, pulling in the air. You'll do your business essentially into a vacuum cleaner. There's a unique funnel-shaped hose end so that both men and women can use the toilet. A suction air stream picks up all the droplets and directs them into the tank. Then comes the whole waste cleaning system with many filters and chemicals. There's also a tank of powerful acid. It's there to dissolve any solid formations in the waste. Otherwise, they can clog the filters and valves and complex systems and cause a breakdown. A leaky toilet is a very unpleasant thing when you're locked in a tight space without gravity. That acid can easily dissolve even some metals. That's why space toilet materials are made of special titanium alloys, super resistant and very expensive. After being cleaned, the waste gets turned into drinking water. It means that with time, you'll turn it into the garbage again and the cycle will repeat and repeat all over. Don't worry, the purification system works exceptionally well, so there's no harm in drinking the water. And your coffee also won't taste any worse. Things are a little more complicated if you run to the toilet for number 2. Then, just like on Earth, you'll have to lift the toilet lid first. At this point, the same fan as in the previous case turns on. It should already be working to prevent bad smells. Then it would help if you sat on the toilet, and here's another challenge. It's hard to do it in zero gravity. So there are straps for your feet and handles to hold on to. The fan does its job and your business goes into the waste tank. Paper and tissues go in there too. Each portion of solid waste then goes into a bag and gets sealed. And then the system sends these waste bags to a special canister. These canisters are stored on the ISS until a cargo spacecraft arrives there. The astronauts receive food and water supplies and scientific equipment. Then they load the cargo spacecraft with canisters of human waste and other garbage. After that, it undocks and prepares to return to Earth. But since cargo spaceships burn up entirely due to friction against the air in the upper atmosphere, all the waste gets disposed of before reaching the planet's surface. Another option astronauts have is to throw the canisters with waste directly into the open space. Earth's gravity eventually attracts the containers, and they too burn up in the atmosphere. Currently, NASA is developing a system that could recycle waste of number 2 into water. After all, water is a precious resource on the International Space Station. So this space toilet, which is a little thing about the size of a scooter, costs around $23 million. That includes manufacturing and a dozen years of development. And this price doesn't even include the delivery to the International Space Station. For that money, you could buy a Bugatti Veyron, the most expensive car in the world, or something similar. Or a private jet, for example. Or you can become an island owner. You can even buy a few of them for that money. But okay, let's get back to space. The journey starts at the launch pad. The rocket that will later deliver the cargo to the ISS is assembled. Ignition! The rocket engines turn on. They burn hundreds of pounds of fuel every second. The rocket goes up, and when all the fuel is burned, the rocket's first stage undocks. It returns to Earth and makes a soft landing. The booster can be used again after refueling. Once the booster is undocked, the rocket's second stage fires the engines. More fuel is burned so that the rocket can reach the ISS altitude of about 250 miles above the sea level. Once in orbit, the cargo spacecraft docks with the ISS, and voila! The space toilet is delivered. But it costs about $50 million to launch a booster rocket like Falcon 9. We also plan to send people to Mars, and the trip will take them about 7 months. So we should create a comfortable bathroom for the astronauts, probably. The design of the 23 million toilets is bound to be improved. Let's wish the engineers to make it smaller and lighter, so this way it uses less space and saves more fuel. Thank you for watching today, Brightsiders, and remember, let's learn something new every day together with Brightside.
Does the universe ring like a crystal glass? Maybe. But it doesn't mean that it literally rings and we just don't hear it. It just vibrates. Many of you know that the universe started with the Big Bang around 13.8 billion years ago. I wasn't around then, but we can assume. The whole enchilada was born from a super concentrated, hot, and dense tiny dot that contained everything. When it couldn't bear its pressure anymore, it made a huge blast and spewed around all the time, space, matter, and antimatter like a Pokeball. After being born, the universe moved at a breakneck speed. Imagine standing in the middle of nowhere, you blink, and suddenly you're surrounded by the universe. That's what it would feel like. It started growing and growing, and eventually, its speed got slowed down a bit by gravity. Gravity started pulling all the matter together, slowly helping new things like stars and galaxies to form. Okay, makes sense so far. The Big Bang gave the universe a big push, accelerating it. Logically, everything should eventually slow down and start moving at a constant speed, or even stop, right? Well, nope. In the late 90s, astronomers discovered something weird. They looked at some supernova around us, and for some reason, these supernovas were super far away, much farther than they were supposed to be. In other words, the expansion of the universe is not only continuing after all these years, but it's even accelerating. After years of study, they discovered the concept of dark energy, a mysterious force that makes up about 68% of the universe's total energy. This energy pushes it to expand even faster over time. And now, scientists have proposed a new discovery. Perhaps the universe's movements are a bit, well, wobbly. It seems like the universe's expansion hasn't been smooth and stable over the years. Instead, it has undergone periods of speeding up and slowing down multiple times. Astronomers counted about 7 cycles of this acceleration and deceleration over the history of our universe. This can be compared to the oscillation of a crystal glass. When you strike a crystal glass, it vibrates, oscillating at its natural frequency. It goes through fluctuations in which the frequency rises and falls. Over time, it calms down and fades away. Well, something like this is happening to our universe. You can imagine its speed also fluctuating like that, rising and falling, first super rapidly and then more calmly. As if it's not just different waves traveling through it, but our entire world is like one huge ringing wave. The discovery was actually made by accident. Astronomers were working on dark matter modeling. They plotted a new graph called the Hubble diagram, which shows how big the universe got over the years, measured in supernovas. Supernovas are like some lighthouses of our world, helping us mark things on a map. That's when they found these oscillations. But we still need to check all the data to make sure that this discovery is indeed true. Dark energy and dark matter play this weird game with the universe, where one is constantly trying to pull everything together, while the other one wants everything to expand. So far, dark energy vastly outweighs dark matter, whose weight makes up only 27% of the universe. Now, both of them are invisible to us, and not just invisible to our eyes like infrared, it's that we literally can't detect them in any way. We can only assume that they exist based on how they influence gravity, changing entire galaxies, and all the large-scale structures of the universe. We basically made them up because it was the only way to explain how our world works. Dark energy is uniformly distributed across space and time, and we're still not sure what exactly it is. Some theories say that it could be a property of space itself, quantum fluctuations, or even a new type of field or particle. But all we have for now is an invisible energy that pushes the universe to move very fast. If one day we learn more about it, this will help us predict the entire fate of our world. Depending on how exactly dark energy works, the universe may continue expanding and growing indefinitely. Or maybe one day, it will experience the Big Rip, where all matter will be completely torn apart. Okay, here's to hoping we're not all around for that. Meanwhile, dark matter, also invisible and yet to be proved, works the opposite way. It's not energy that accelerates things. Instead, it's more like a glue that tries to hold everything together. It's a type of matter we can't detect because it doesn't emit, absorb, or reflect light. We don't even know what particles make up this thing. We still can't catch them. At first, we thought it might be made up of regular heavy particles, like the one that makes up our world. But after years of research, they haven't found even a single one. So now they think maybe it's actually made up of ultralight particles, millions of times lighter than anything we know, and because of that, we can't even notice them properly. So now, astronomers try to detect not the particles themselves, but waves that they could leave as they move through space. But we believe that it exists, because if it didn't, our galaxies wouldn't hold together. Dark matter helps them form, grow, and rotate. So, about 85% of our world is made of something unknown. All of this is incredibly mysterious and needs a lot of research. But that's what we know now. Maybe in the future, we'll discover something that will completely change our perception of the universe. That's what happened to Albert Einstein. In the early 20th century, most scientists, including Einstein, believed that the universe doesn't actually move. They thought it was static, neither expanding nor contracting. That's because, to us, it feels like it doesn't really move. Back then, scientists didn't have powerful computers or telescopes that could detect all the little changes in the positions of stars and supernovas. When Einstein developed his famous general theory of relativity in 1915, his equations actually suggested that the universe should either be expanding or contracting. This didn't really make sense to him. To fix this calculation flaw, he decided to introduce a new term, the cosmological constant. It was like a repulsive force that counteracted the attractive force of gravity. Essentially, it meant that while gravity tries to push everything together, some force or energy helps to balance this out by pushing everything apart. Sounds familiar? Then, in the 1920s, astronomers Edwin Hubble and Georges Lemaitre found out that the universe isn't static, it actually expands. They noticed a slight reddish tint from the distant galaxies, and this tiny hint meant that other galaxies were moving away from us. After that, Einstein scratched out the cosmological constant. Interesting how he was later ashamed of this assumption, calling it his greatest blunder. He didn't even know that he was 100 years ahead of his time, accidentally discovering dark energy. Now the cosmological constant is back again, just in a new form. Something similar happened with dark matter. Scientists have already started noticing that something doesn't add up back in the early 20th century. They saw that galaxy clusters didn't have enough visible mass to hold them together, which means there must be some unseen mass that helps to make up for it. And that's when it got its name, the dark matter. This stayed unresolved and unproven for many years. And then, it was finally discovered by Vera Rubin when she was observing galaxies and their movement. She realized that outward parts of galaxies move almost as fast as their central parts. This doesn't really make sense. The outer part should be a bit slower. This became the first official proof of dark matter, which boosted its research. There are still many things left to be discovered. But maybe one day, we'll understand what is this invisible part of our universe that makes it ring. While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them. So it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it. And just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical ninth planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Batygin have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry. They say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, The hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigeon's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there. Dark, mysterious, cold space. Comets, asteroids, planets, stars, and something that's lurking over there, far beyond Pluto. Yup, this could be the 9th planet of our solar system, the one people have been wondering about for centuries. IRAS, which stands for the Infrared Astronomical Satellite, collected interesting data back in 1983. It could be proof that Planet 9 is hiding there. No one knows if it really exists, but this discovery helped to build a model to understand this potential planet better. And in 2016, scientists found out that some small space objects in the Kuiper Belt were orbiting a bit oddly. The Kuiper Belt is the outer area of our solar system. It's a ring in the shape of a donut, filled with leftovers from the times when our solar system was forming. You can find this donut beyond Neptune. The objects in that region of space have weird orbits, almost as if a big body with strong gravity is pushing them away. Knock knock, Planet 9 again. The theory says it might be 5 to 10 times the mass of our own planet and up to 20 times further away than Neptune. The astronomical unit equals the distance between our planet and the Sun. Pluto is approximately 40 astronomical units from the Sun, but Planet 9, if it exists, is 400 to 800 astronomical units away. It would take 10,000 to 20,000 Earth years for this mysterious planet to make a single circle around the Sun. This makes it harder for us to catch this space body. There's a theory Planet 9 may have formed between the orbits of Jupiter and Neptune, similar to the rest of the gas giants in our solar system. The gravitational force of one of the two huge planets probably kicked it out of its orbit. Oh no. Then Planet 9 could get ejected further away from the 8 planets we know about. It ended up as some sort of icy waste, quite small at the beginning. But as time went by, Planet 9 has cleared its orbit of frozen pieces of rock and dust and finally formed into a real planet. Another theory says that this could be a planet another star lost on its way while it was passing near our solar system. In any case, Planet 9 probably doesn't reflect that much sunlight since it's so far away, and astronomers aren't sure where exactly they should look for it. Space is dark, mysterious, endless, obviously. But if we do find Planet 9, it will be the first solid proof there are more planets in our solar system than we thought. Moving on to an interesting exoplanet, located only 90 light-years away from us. An exoplanet is generally a planet located outside our solar system. This one has an atmosphere with water clouds. 1 year there lasts 24 Earth days, and the planet travels around a red dwarf star, which is way dimmer and smaller than our Sun. That's why, even though the planet is 8 times closer to its star than we are to our Sun, the temperature there is similar to that on our planet. This exoplanet has a size similar to Neptune. It's also less dense, which means it's mostly made of gas, unlike Earth, which is made of rock. The average temperatures there is 140 degrees, which makes it one of the coolest small exoplanets we've ever discovered. And the cooler the exoplanet is, the bigger the chance we'll find clouds in its atmosphere. Researchers have discovered more than 4,000 exoplanets, but all of them have been found within the Milky Way, at least until now. For the first time, astronomers may have spotted a planet outside our galaxy. They called it M51 ULS-1. The planet is located in the Whirlpool Galaxy, a distant spiral galaxy 28 million light-years away from us. There was once a huge but pretty young star that got stuck in a gravitational dance with something that could be a dense neutron star, the collapsed core of a giant star, or a black hole. The star's dance partner had incredibly strong gravity. It was feeding on the star, greedily ripping away its plasma. Then something unusual happened. An unknown, maybe even Saturn-sized object passed by and blocked this confrontation from our solar system. Now, no one can see what is going on, but this could potentially be the farthest planet we've ever discovered. There's a newly discovered planet outside our solar system. As large as Jupiter, it orbits 2 stars, and as we can observe it from our planet, it crosses in front of them both. The full circle around these 2 stars, which means 1 year, takes approximately 200 Earth days. On the day of the discovery of the previous planet, scientists also found it had an unusual companion. It's an extra-hot Jupiter with an ultra-tight orbit around its star. The year there lasts only 1.9 Earth days. This planet has a weirdly shaped orbit. Also, it travels in the opposite direction from the rotation of its star. If you could travel 57 light-years away from our planet, you'd see something pink lurking in the darkness. As you get closer, it becomes bigger and more fascinating. Yup, it's a magenta-colored planet. A few billion miles away from its sun, this guy is one of the youngest planets scientists have discovered. It's only 100 to 200 million years old. It's made of pink gas, similar to our Jupiter. So, if you could fly closer to its surface, this gas would envelop you like a thick fog. You're coming closer and going deeper, and the gas is becoming darker, getting a reddish shade. And look at the planet's core. It's super hot. Because of its high temperature of 460 degrees Fahrenheit, this planet is like an oven. The heat is the reason the planet glows so brightly. You'll also notice the sky is hazy pink, with clouds made of droplets of frozen water, similar to ours. There's another exoplanet half as massive as Earth, which is one of the smallest planets we've ever found outside our solar system. It has a diameter of 5,600 miles. For comparison, Earth's diameter is 7,900 miles. The planet in question is mostly made of iron, similar to Mercury. Mercury has a massive iron core and a very thin crust, which makes it an oddball in our solar system. At its early stages, it collided with some space body at least once. That collision pulled its outer layers away, which is why only the firm iron core remained. Maybe this exoplanet participated in a huge space crash too. That's what probably took away the planet's mantle and left mostly its iron core. Or maybe this is just a remnant of a gaseous planet that used to be the size of Neptune. The atmosphere of the planet could be blown away by, let's say, a huge amount of radiation coming from the star. This planet is only 31 light-years away from us, and the day there is less than 8 Earth hours long. The planet is only a little bit bigger than Mars. People aren't likely to ever settle in that place because of its extreme temperatures that go up to 2,700 degrees Fahrenheit. There might even be molten lava on the side of the planet that faces its star. Such temperatures are high enough to evaporate any atmosphere, so this planet might have had one in the past. Generally, gas giants like Jupiter can't support life because they have extreme weather conditions, temperature, and pressure, and there are no building blocks that might create life. But smaller terrestrial planets, such as, Earth, have more key ingredients like oxygen and liquid water. Plus, they have more temperate weather and other conditions. And still, not all of such planets support life, of course. It's not easy to find a planet with similar conditions as the ones we have on Earth, or at least the conditions that would allow life to develop there. But meet Kepler 22b, one of our most promising findings. It's 600 light-years away from us, twice bigger than our planet, and with temperatures of about 72 degrees Fahrenheit. This is a so-called super-Earth. It's a category of planets unlike any we have in the solar system. They're more massive than Earth, but still lighter than ice giants such as Uranus or Neptune. Super-Earths can consist of rock, gas, or a mixture of these two. Kepler 22b is within the habitable zone of its parent star, which is less bright than our Sun. The planet probably has a rocky core. It may have an ocean, but it doesn't host any life. At least, we don't know about it yet.
Did you know that humans are real space people? You were born in space. Heck, even I was born in space. We were all born in space. But for humans to be here on Earth, so many conditions have to be precisely correct that it's highly improbable that we even exist. But we do. First, we, and any other space creatures who might be out there, have to live on a planet orbiting a yellowish white star, not a red star or a blue star. Not a blue star, because they burn out too quickly. in a few million years, there wouldn't be time for evolution to do its relatively slow magic and produce intelligent beings. Blue stars also tend to swell up and turn red when they collapse and explode. It makes it highly unlikely that any civilization could prosper near a blue star. Red stars, which are by far the most numerous kind of stars, don't seem like good prospects for intelligent civilizations to orbit around either. Red stars are so cold and so dim that a planet that could grow a civilization must orbit very closely to the red star, which would expose the planet to intense, deadly X-ray radiation. So, though red stars are the most numerous and appear to have many planets orbiting them, red stars are a no-go for hosting intelligent, civilized life like our own. That leaves the yellowish stars, about 10% of all stars. However, an important fact must be met before considering the possibility of intelligent life living around a yellowish star. That fact is that the yellow star must be a third-generation star. Only third-generation stars will contain sufficient chemical diversity to sustain advanced life forms. Each time a star explodes, heavier, more complicated elements are created. The explosion expelled these elements and eventually found their way into a nebula. Gravity within the nebula will gradually form the next generation of stars, and so on. Our bodies need calcium for our skeletons and teeth. Our brains need zinc to help create the electrochemical signals that make us move, feel, and think. Our blood needs iron. Therefore, our bodies need to have formed around a third-generation star, and a yellow one. Amazingly, Earth has all the different elements in the universe, all 94 naturally occurring ones, from hydrogen to plutonium. Maybe that's why we're here. And we have to thank our third-generation yellow dwarf sun for that. Why yellow? Because yellow stars burn very steadily by nuclear fusion without significantly changing brightness over billions of years. If our sun became just 6% brighter or dimmer, Earth would become too hot or too cold to sustain civilized life. Fortunately, Earth is in the habitable zone around the sun. The habitable zone is where liquid water can exist on a planet. But that brings us to the second condition necessary for intelligent life to live in space: the planet itself. Recent studies with the Kepler telescope have shown that 1/4 of all yellow dwarf stars may contain Earth-like planets in the habitable zone around yellow dwarf stars. That figure is somewhat debatable. It might be as few as 1 out of every 33 yellow dwarf stars, but that's still a lot of planets orbiting yellow stars in habitable zones. So let's consider the second essential component for intelligent life in space: the planet itself. The planet that would bear intelligent civilization must have many particular characteristics that aren't easy to come by individually, and even more rare to find in combination. Most importantly, the planet must have protection against the star it's orbiting. Because stars shine by nuclear fusion in their cores, gas in the outer shell of the sun, called the corona, gets blown off into space in what's called the solar wind. Our United States satellites take constant readings of the force of the solar wind, which is mainly electrified, ionized, hydrogen nuclei, along with a smattering of atomic nuclei from the many other elements found in the sun. It's not the atmosphere that protects Earth, it's the magnetosphere that stops or deflects the dangerous solar wind, causing aurorae when the solar wind is attracted to Earth's magnetic poles and electrifies the air of the upper atmosphere like a fluorescent bulb. Without a magnetosphere surrounding it, any planet, even those in habitable zones, would be toasted by a constant rain of ionized hydrogen nuclei from its star. A planet with life on it must have a magnetosphere strong enough to deflect the solar wind. Not every planet in our solar system has a magnetosphere. The gas giant planets, Jupiter, Saturn, Uranus, and Neptune, have magnetospheres, but gas planets cannot have civilizations. Of the solid worlds, only Earth and Mercury have magnetospheres, and Mercury is too weak to stop the solar wind because of its closeness to the sun. Another protective shield that keeps the Earth safe from the sun is its atmosphere. The atmosphere is about 300 miles thick, with most of it concentrated within just 10 miles of the Earth's surface. The atmosphere protects life on Earth from both the sun's ultraviolet, UV, radiation, and X-rays. The gas, ozone, which is 3 oxygen atoms bound into a large gas molecule in the upper atmosphere, blocks most of the sun's UV radiation from reaching the ground. The planet Mars, whose atmosphere is 1,000 times thinner than the Earth's, has no ozone, and the sun's ultraviolet emissions have totally irradiated its surface. A planet must be able to stop the UV radiation from its star, so the specific composition of the atmosphere is critical for any planet to have an intelligent civilization. We've got it, but it is a rare and precarious mix. The planet must have some part of its surface solid to walk and work on. The planet must have a crust. It's pure science fiction to consider underwater civilizations or floating civilizations in the atmospheres of other planets. A planet's crust must have tectonic plates that move. This movement of tectonic plates creates the subduction of the crust. Subduction is when one tectonic plate slides under or over another, bringing the fresh matter to the surface. This renewal of the chemical properties of the planet prevents chemical equilibrium, where nothing is reactive. Earthquakes and volcanoes also contribute to the process of geochemical renewal. That's right, earthquakes and volcanoes are good. Subduction of tectonic plates, then, is another planetary essential for life. Mars doesn't have tectonic plate activity. Neither does Venus nor Mercury. Mercury is one big tectonic plate, but there's no ongoing plate activity other than slight shrinkage. One big reason these planets have no life is that there's no geochemical reactivity because there's no tectonic subduction. And that brings us to the Moon. Yes, the Moon. To say that the Moon keeps us alive may seem like a stretch, but the contribution of the Moon to life on Earth is essential. First, the gravity of the Moon as it moves through space with the Earth not only makes the ocean tides ebb and flow, it also helps the rotation of the Earth to churn or stir the magma inside the Earth. The motion of the magma inside the Earth, with its high metallic content, contributes to the creation of the Earth's magnetosphere. So, the Moon keeps us safe in space by helping Earth become a geodynamo and creating our magnetism. The Moon is the largest moon in the solar system compared to the size of the planet it orbits. Essentially, it's primary. Many people consider the Earth-Moon system to be a double planet, but that's another issue. Another thing the Moon does that keeps life safe on Earth is to hold the Earth steady. Because the Moon is gravitationally locked to the Earth, the Moon acts much like a balance pole does for a tightrope walker. Therefore, the Earth doesn't wobble very much compared to other planets. This wobble is called libration. If the Earth wobbled as much as Mars or Saturn, not only would our weather become chaotic, but farming might have been impossible. These rare or unique astronomical circumstances work together to make Earth habitable for humanity. Many other factors are not astronomical, such as evolutionary, biological, and chemical factors required for life to exist on Earth. The probabilities, or improbabilities, are multiplying. Taken all together, we are very, very lucky to be here. In fact, we're so lucky that we may have hit the jackpot. Considering all the possibilities, it's doubtful that anywhere else in the universe is as fortunate as Earth. Our solar system might have some more planets up its sleeve. We know about 8 official planets, but they're not the only ones that survived the chaotic formation of our solar system 4.5 billion years ago. Astronomers say there are 3 categories of planets in our solar system. We're in the first one, the 4 rocky inner planets, Mercury, Venus, Earth, and Mars, that peacefully orbit the Sun. They're located within the main asteroid belt that separates Mars from Jupiter, which is in category number 2. That one's a group of planets in the outer solar system, the gas giants, Jupiter, Saturn, Uranus, and Neptune. These planets have huge amounts of ice and gas around what scientists believe to be their rocky cores. The third group lies beyond the area where our local planets are, somewhere further than Neptune. It's the realm where you'll find dwarf planets such as Pluto, Eris, and Sedna, and many smaller space bodies like comets. But new findings say there could be something else lurking in the dark, besides dwarf planets and tiny space bodies. Maybe even a new planet. Models scientists made say that our solar system used to have 1 or more rocky planets, the size of Mars or Earth. Over time, these rocky wanderers interacted with the wide gravity fields of our gas giants. This kicked them into a far-out orbit, away from the neighborhood. The question is, if one of those Mars-sized planets survived and could really be somewhere out there. Scientists have made simulations to see what potentially happened. These showed that in half of such cases where planets interact with the gravity of gas giants, they get ejected into interstellar space. In the remaining half, there's this one rogue planet left in an orbit similar to the ones the Kuiper Belt objects are following. There's only one thing left to do now: find it. Astronomers found the loneliest planet in the universe. They were trying to find distant brown dwarf stars, or failed stars, ones that never become massive enough to start shining. Stars are born with big masses, which means they also have strong self-gravity. The star squeezes in on itself. That causes high internal temperatures and enables the star to shine. But instead, they found a lonely wanderer, CFBD SIR 2149. The planet is between 50 and 120 million years old and has a surface temperature of 750 degrees Fahrenheit. Compared to stars, that's cold. At first, scientists thought it could be a brown dwarf star, but in that case, it would be way older. This starless planet floats around through space, passing only 130 light-years away from our planet. Our galaxy, the Milky Way, is 100,000 light-years wide, so that's relatively close. The lonely traveler is actually a gas giant, 4 to 7 times bigger than Jupiter. Maybe it was kicked out from its own solar system because of gravitational forces, or getting into another planet's orbit. Or it was formed away from its parent star. Far beyond Pluto, on the edge of our solar system, there's a space body about as big as Pluto, but a little bit colder and way denser. It's probably a big rocky body covered in a thin icy mantle. It's the dwarf planet Eris. Both Pluto and Eris occupy the Kuiper Belt, which is the distant ring of frigid space bodies that lies beyond Neptune. A day there lasts 25.9 hours, pretty similar to Earth. But Eris circles our sun in the distance 3 times farther than Pluto, which means its year is pretty long, 557 Earth years. Eris has a bright, icy surface. It's one of the most reflective bodies in our solar system. It bounces back more than 95% of the light that strikes it. Somewhere out there, even farther, there's a super Saturn, J1407b, much larger than Jupiter or Saturn. It's an exoplanet, which means a planet that orbits a star other than our Sun. Super Saturn is 434 light-years away from Earth in the constellation of Centaurus. It's the only exoplanet we know about with rings similar to Saturn. It actually has a huge ring system, 200 times bigger than Saturn's rings. There are more than 30 rings, each of them tens of millions of miles in diameter. There are gaps in the rings, which means there could be some interesting satellites, exomoons, around. If this super Saturn could swap places with our regular Saturn, its rings would absolutely dominate our sky. You could look up and easily see them. The view would be amazing because they would appear much bigger than a full moon. Scientists have found thousands of planets outside of our solar system. Some are dense as iron, while others are airy and light. And then there's the water world, GJ1214b, a steamy world, bigger than Earth and smaller than Uranus, 40 light-years away from us, in the constellation of Ophiuchus. It's a watery planet surrounded by a thick atmosphere, 2.7 times Earth's diameter, and almost 7 times heavier than our home planet. It was most likely formed somewhere farther from its star, where there was plenty of water ice, but later migrated to where it is today. Its surface temperature is 440 degrees Fahrenheit, which is too hot to host life like on Earth. It also has much less rock and much more water than our planet. Imagine a planet with no land, but only endless oceans covering all of its surface. High pressures and temperatures would form things like superfluid water or hot ice, some pretty exotic materials that we can't see on our planet. Gliese 436b. It's a Neptune-sized exoplanet 30 light-years away from our planet in the constellation of Leo. It makes one full orbit around its star in a little more than 2 days. This planet defies the laws of physics. It orbits its star, Gliese 436, which is smaller, cooler, and less luminous than our Sun, at a distance 15 times closer than Mercury is to the Sun. When we typically think of ice, we picture a frozen cube. But this planet has an icy surface, even though the temperature there is 980 degrees Fahrenheit. This temperature is way above the melting point, but the ice remains solid and burning hot. This happens because of very strong gravity. It compresses the water vapor in the atmosphere into solid ice. The pressure here doesn't allow the ice to melt, no matter how hot the surface is. Now imagine being on a mysterious planet and it suddenly starts raining sapphires and rubies. One distant exoplanet, HAT P7b, a gas giant 1,000 light-years away from Earth in the constellation of Cygnus and 16 times bigger, has specific weather and pretty violent storms. Rubies and sapphires are scattered across the planet when it's raining. On the planet's night side, there's a high amount of corundum in the atmosphere. And corundum is what mineral gems such as sapphires and rubies are made of. Clouds of corundum give such an amazing view. The planet is plagued by severe winds that often turn into powerful storms that push huge masses of those clouds across the planet. Although the planet is uninhabitable, it would certainly be cool to come there and pick up some gems. Still, the weather is pretty wild. Plus, the temperatures are over 4,600 degrees Fahrenheit. By comparison, Venus is the hottest planet in our solar system, and its temperature is only 900 degrees Fahrenheit. Looking over the expanse of space, you can see a beautiful little blue dot in the endless darkness. It's an exoplanet, HD 189733b, that lies 63 light-years from us in the constellation of Vulpecula. But it's way hotter and larger than our planet, around the size of Jupiter, and it completes its orbit around its host star in only 2.2 Earth days. That orbit is so close that the planet is most likely tidally locked. That means it's always showing only one face to its star, like our moon always shows one side to Earth. The weather here is crazy. The winds blow at up to 5,400 miles per hour, which is 7 times the speed of sound. The fastest wind on Earth only hit the mark of 230 miles per hour. And it gets better. The rain here is not made of water, but of molten glass. Clouds are made of silicate atoms and particles. They are the key element that gives the planet its cobalt blue color, not the reflection of oceans, which is the case with Earth. Earth used to be purple. Today, even when you look at our planet from space, you see a lot of green. The green we see in nature is there because of photosynthesis, the process where plants transform energy coming from the sun into energy they need to live and to produce oxygen for us. The main part of the process that gives plants the green color is the chlorophyll pigment. A long time ago, instead of chlorophyll, there was a molecule called retinol. Its pigments absorb yellow and green light and turn it into red and blue, so the Earth was more purple. And then there's a pink planet, GJ504b, far away from us, in the Virgo constellation. 4 times more massive than Jupiter, it's a newly formed exoplanet, around 160 million years old. By comparison, the Earth is 4.5 billion years old. If we could go there, we would see an incredible world that glows from the heat of its formation. Everything around you would be colored magenta.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, It is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the sun's blinding glare. So, every time there was an eclipse, scientists would peer at the sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart, The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from 2 special space surveys called ERAS and ACARI. These 2 looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both ERAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The 2 detections weren't in the same spot in both surveys, and the way they appeared in the ACARI map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be 2 unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we